All right, so the first one is called external standard. This is the most uh, commonly used, and this is quite uh, simple, very simple. Uh, if we are working with standard solution in the lab, okay, and we are not involving any outside sample or raw sample. So this is the best to be used, external standard. And what you do is you prepare the chemicals, the salt or the chemical reagents in concentration that you already calculated, you already knew. You weigh the salt, you weigh the chemicals, and you dissolve it in proper solvent, and you have a fully dissolved solution. Make sure it is fully dissolved, because if it is not dissolved, then the measurement will be inaccurate. Okay, so proper dissolution steps are very important. So there are a few steps that you can do to properly dissolve. It's either, if it is possible, to add a bit of acid, or you can do microwave assisted, or you can do sonicators. Yeah? You can sonicate the solution to dissolve the whole thing. Yeah, right. And then in order to prepare a series of standard solution, you can do dilution. Okay, uh, to prepare different concentration of standard solution. But be careful when you dilute, you propagate the error. So let's say you have an error from the stock solution when you are trying to dilute to different concentration. Remember that you might be propagating the error that you start from here. All right. So this is, well, requires practice and requires a proper glassware. For example, micropipette, suitable micropipette. If you really need a very low concentration, make sure that you have suitable micropipettes, capable of preparing very low volume of the chemical reagent. Right, so this is the easiest, definitely the easiest. You can just dissolve it. Yeah, all right. So this is an example. Yeah, so in this case, well, the study uh 2,3 butane. I also have difficulty in organic chemistry. Butanedione is a ketone in beer. A headspace GC method is utilized to separate the various components in beer. A series of standard solutions are created to define the instrument response to varying concentration of analytes. So specifically, a stock solution is created by adding a specific amount of diacetyl primary standard to a solution of this cloth. Okay, so this is just involve calculation of molar and then dilution equations. So you are very familiar, I think, with C1 V1, C1 initial concentration, V1 usually is unknown. You the one that you need to calculate. C2 is the final concentration and V2 is the final volume altogether. So this is something very standard. Okay, so commonly used in the lab. So there's no issue in this. But if you're talking about having samples from somewhere like river water, like uh, industrial water, or probably bodily fluid like uh, serum, then we have to consider the matrix effect. So I think I have discussed a bit on the matrix effect. Matrix is the other compounds that exist in the sample that is not our interest, but it is there. Okay, definitely is there. And this is very important technique because in order to eliminate the effect of the matrix, we have to use this standard addition method. So the standard addition method is similar to the external method in the concentration of an analyte. However, the standard addition method, the standard is added to the sample to correct metric effects. So I'll show the picture. I think this is something that I have shown before. So blank is definitely no analyte of interest in there. Okay. And then sample unknown is the sample. Okay, let us just think about sample from river water. Okay, so you can see that the blue volumes are all the same. They are all similar. So you took the river water samples and then you put here with all the same volumes. Okay, let's say, and then you put the analyte of interest, but the one that is standard. Okay, I think I have an example. Just do. Okay. Now, let's say we want to analyze the lead content in the river water. So we took the river water here and we fill up the beakers with same volume for all the five beakers. Okay, and then you prepare a standard solution, a lead solution. Okay, and then we put a series of volume of standard solution of lead into the beaker. So you have to be aware of the final volume. Yeah, you have to be aware of the final volume when considering the calculation after this. Okay, so now let's look at what is this method. Okay, this is called spiking. This can be done for a single sample or for calibration curve. So if you are doing a single sample, it can also be done for spiking, or you can do for a series of sample by using this spike method. When using a calibration curve, we have a series of increasing concentration. Okay, then we can plot the calibration graph. Okay, so this one we have discussed. So look at the examples. So that's why you see, even though concentration of lead standard in the same is 0, but there is this is signal for baseline probably. Okay, so now once you have done that, you do the measurements and get the data, the signal, and you can use this formula, okay, to calculate the concentration of analytes. Okay, so concentration here, if you look at concentration of analyte in initial solution, divide by concentration of analyte plus standard in final solution. All right, so this one it comes from the measurement. If you're using, for example, UV, then you get the signal from absorbance, signal from final solution. So what does it mean by final solution? It's the total. Okay, so if we look at the formula again, concentration of analyte in initial solution divided by concentration of analyte plus standard. Standard is the yellow one in final solution. So final solution, you have to consider the volume. Yeah, the volume standard and initial solution. Okay, all right. So another way of preparing standard is internal standard method. This usually especially used in chromatography, okay, whether you are using GC, gas chromatography, or you're using liquid chromatography. So internal standards are very important where you do this kind of analysis. Internal standard should be a primary standard. Okay. So what is a primary standard? There are some characteristic. It has to be pure. It has to be stable. It does not react to what environment. So there are certain characteristic that we can use as a primary standard. Okay. So in an internal standard is an analytical chemistry in sorry, internal standard in analytical chemistry is a substance that is similar to the analyte. Okay, that is added in constant amount to the blank, the standard, and the samples. Okay, so we need to have that because they are useful to compensate for changes in extraction efficiency, or there is a detector response to the sample loss during sample preparation. I will give you example here. Okay, example here is analysis of fatty acid, lauric acid, is found in coconut oil and many other plants. Okay, it can be quantitated by GC, gas chromatography. The method involves injecting a few microliters of each sample into the instrument. So we can imagine that when you are injecting a few microliters, there's a possibility of, because it's volatile, you might miss some of the samples to the environment. So this is difficult to do precisely, okay? Precisely, especially because the sample solvent is highly volatile and is evaporating as it is transferred from sample vial to the instruments. Yeah, probably we are using auto samplers, but still, because it's highly volatile, you might miss some amount. So for the analysis of lauric acid, the internal standard, nonanoic acid is added to each sample. Okay, so the response factor or response ratio controls for the fact that the internal standard is chemically different than the analyte and may respond differently to the assay. So we have to calculate the F, yeah, the F factor. So what we do is where X and S are the concentration of X, which is in this case lauric acid, and S in moles per liter. S is the standard, the internal standard, and AX and AS represent the signal. So depends on what kind of detector you're using in the chromatography. So this one is the signal generated from the machine. Yeah, this one is the concentration of the analyte, which is lauric acid, the one that we want to measure, and S is the internal standard concentration. So we have to find the F first before we can do further calculation when using internal standard. Okay, all right, so this is something that you need to be alert of when you do sample preparation, standard sample preparation before the calibration plot, because which method that suits the samples. Okay, it has to be based on the sample. Okay, so now, since do you have any question on this? We are moving to the looking at the question for assignment. All right. Any question on the standard preparation? Okay. So everybody is nervous on the presentation after this? Okay. Right, stop share this one. Okay. Now. So I'm showing some the first time, the first time for you to look at how your assignment, group assignment will be, yeah, so that you have some ideas how it will be. Why is it okay? So the first assignment is individual and it's more like tutorial, right? It's more like tutorial. You can just use the existing formula and do a calculation, and that's it. You can settle all the assignment. But for the group assignment, this will be more on data analysis. You have to read through the modules and you have to uh, really study the data and answer to a series of required for you to complete. So this is what we call as problem-based uh, PBE, problem-based PBS, problem-based study. So we use the information that you have obtained to solve a real problem. So for this kind of group work, I don't really search for the accurate answer. It's more on the process. It's more on the process of you identifying the data, analyzing the data, and you use all the resources, all the information that you have obtained from the beginning, on the sampling, on the what you have understood in order to solve these problems. So there are 4 problems. So the first will be the room number 1. I hope, yeah, I don't remember the groups. I forgot to screenshot. So I hope that you still remember all your groups. So the first one is called the pale horse. I don't know why it is called the pale horse. A problem-solving case study in analytical chemistry and forensic science. Okay, so problem-based study, usually the problem is a bit general, meaning that it can be viewed in analytical chemistry point of view, and it also can be viewed in forensic science forensic science point of view. So now we are looking at it in the form of statistical data analysis and sampling. Yeah. So that depends on what you want. That is problem-based study. You have to look at what point of view. Okay. So this one is obtained from Royal Society of Chemistry. It is in UK, and you can also be one of the moving. One of the member in Royal Society of Chemistry. So this is the resources prepared. Okay. All right. So what's the purpose of having a problem-based study? Is to teach, okay, analytical and applied chemistry within a real life context, yeah, by developing problem solving and professional skills. Yeah. So this is also, yeah, something that we have to do to make sure that our students have what we call as soft skill. So it's not just about formulas and calculation without knowing what you will do with the formulas future. So these present extended problem are set in a real context with incomplete, or it comes with data, but you have to read the whole story to understand. Okay. All right. So there are few that I have chosen for 4 groups. So we have the first one here, Pale Horse, and second one I will show it to you, the Titan project. Okay. Let's continue. So what's the aim of case study? Uh, this problem-based study sets analytical chemistry within the real context of a forensic investigation. It's okay for, I mean, it depends on what problem that you get, which title your group will get. So you can, but the style is similar. The case study operates by supplying information in the forms of reports from various official agencies. You will also, some of you might have, some of the groups might not have a complete data, but it's okay. It can be hypothetical as well. So for this pale horse, you have a lot of data. So the disciplines covered: analytical chemistry, toxicology, forensic science, forensic pathology. So it's not an issue about if it is toxicology, because you're not supposed to do the analysis. The data is provided for you. So what scientific knowledge will be obtained from this is matching analytical techniques to the application, organic analysis, inorganic analysis, and forensic science, manipulation and evaluation of information and data to make realistic decisions. So that is the final aim. So that's what we want. After some measurement, after some data analysis, and then you do some statistical analysis, we want to have realistic decision. Okay. In this case, I think I have shown you the murder scene first time, the first lecture, the first discussion. Uh, so what is the aim is the student should be able to determine that the poison used was thallium. This is the answer actually. This is final answer. Okay. It was administered in a goose wine that was also used to make a chicken. What is this? I don't know. The motive and opportunity of the various suspects are determined from anecdotal evidence. So the case study, okay, this is about the level. So this is what should be the conclusion. But as I mentioned, that is not my concern. My concern is how the process of you getting to the final conclusion. So what skills that you should be obtained from this and other project as well is communication skills, oral presentations and report writing. So oral presentations, it's not really a formal presentation, but it's a series of meetings that you have to do within your groups, and it has to be recorded, and it has to be submitted to me. Um, After, yeah, you will need some time to do this. And of course, you have to do a complete report writing. Yeah. All right. Other one is processing reports. Okay. So the minimum contact time, okay, this is what you should spend in solving this PBL, problem-based learning. How can the activities be accessed? All right, so students can be accessed in various ways, including case summary, group or individual report, or presentation and individual contribution. Okay, that's why I need the recorded video of your meetings. All right. Okay. So this is for the first problem. Okay, this is too big. Okay, there is suspicious death, and then you have a crime scene. You have to read the evidence, you have to read the data, and then in this case, because we're not talking about forensic, but still you have to think about the motive, because it's a murder. Then you need to think about the motive in order for you to analyze the data, analyze the possibility of, is it poison? Yeah, because I have told you it's a poison, but then by right it should be based on the first one is crime scene, motive, time of death, and then a series of data. and then we look at the results, and if any further evidence that you requires, and finally is the presentation of the findings. Okay, this is how it should be. So we have I have divided you into 4 groups, I think. Yeah, 4 groups. Correct. Correct me if I'm wrong. 4 groups of you, right?
Yes, doctor.
Yes. Okay. Thank you. So, right. Introducing the case. So I'm introducing it right now. Okay. All right. And then overview of the case. Okay. You have to read everything. Okay. So I will give time. Don't worry. You have to read the data. And then if you ask, you can hypothetically request for further analysis if you wish to. Okay. And right. So this is example, for example, ICP-MS with the urine of the dead body. And these are some examples of the results. Okay. So what from here, you have to know what is the safe limit. Okay. And from the results, you can have a suspicious of, it's a possibility that what is the murder due to, or the death, the cause of death due to. Right? How flexible is the case study? The case study, okay, this one is the, so assessment scheme, this is not for you, okay? Don't worry, I will try to give you the rubric next week. Okay, so this should be the one. So overall aim, uh, student given the reports. So I have divided into groups, and I will share these reports to all of you. But you know already that this one is for group 1. Okay, to consider the poison was caused. Okay, was used from the forensic. All right. Okay, this is also another very good practical, is about collection of physical evidence. I think we have also discussed this during the first discussion class. All right. Let's move faster. Right. How does it look like? This is actually will not be given to you. The one that is will be given to you is this. Yeah. This is the detail. Okay. Uh, So you are part of the investigation team. What evidence do you want to collect? So you have to answer all these questions along the way. What evidence that you want to collect? Okay. So this is the skills that you should obtain from this problem-based learning. Consider what samples to take, decide suitable methods of analysis, identify cause of death, decide what further evidence, consider who the likely suspects, and you have to study the report. Okay. Okay, and then you have to fill up this request submitted by investigation group, because you are the one doing investigation. So you need to fill up this form. You collect physical evidence, and you know what you want to identify, so you can suggest method of analysis, and what you're looking for, and what evidence is this from. Okay, for example, here sample from staining on wall in room, identity of the stains, because you do not know what is the stain, so you suggest using FTIR. So this is considered a task. You have to fill up the form. So the next one, okay, you still have to read all the reports. Okay, now is the toxicology part, but yeah, you still have to think about it. Which part of the toxicology sample, the toxicology sample that you want to do, you want to send for analysis. Okay, in this case, it has given to you blood from victim, so you may suggest other parts. Okay, and what you want to look for. All right. So this is information that you have typical element levels in blood. This is the standards. Okay, that should be there. Okay, now very detailed. Remember to read all this. Now, if you have additional evidence, you need to uh, submit more requests for analysis, then you can use this form. Okay. You can try your best to use this form to write, use this question, okay, possibilities, your suspicion, okay. Okay, so when you have this regroup with the team members, okay, you probably thinking about a short meeting, okay. So you record the meeting and you discuss about this, and then you make sure that this is submitted to me finally. And now you have all the results that you have requested. Okay. This is where you need to analyze. You really need to look at the data. All right. So I think the rest of the documents are all in data form. You have ICP, you have even you have appendix for the toxicology. Okay. So everybody probably when you do the first meeting, you can divide your team who's going to look at physical evidence, who's going to look at toxicology. Then this should be the the way of solving this second assignment, the group work. So in you probably need to have a few sittings, means a few discussion. One probably for dividing the group, the work, the task, and then regroup, report, and probably another sitting to summarize. That's the minimum, I think. But if you need more than that, then yeah, you can do that. But you still you have to fill up all these required uh forms, yeah, together with your written report later. Okay, that will be the group one. Okay, group one, do you have question? But it's okay. I mean, I know you need time to read first. You just read first. Okay, next week we are going to discuss a bit on sample preparation again, a few things more. And then we're going to have some session. If you have any question, I try to answer on the group assignment. Okay, the second part, the second group, which is room 2. Okay, this is called Titan Project. Okay, so the purpose of having this is to solve a problem in industrial and analytical chemistry. Okay, this is the same things that the same introduction. Okay, so what's the problem? Let's move on. Okay, this is about titanium oxide chemistry. Uh, it's about deciding uh, to build chloride plant. Okay, and then you have to do survey methods for how to analyze chloride in effluent, industry effluent, and you have to do statistical comparison of the methods, and then you have to choose which method. Okay, so this is basically what you have to do for group 2. So let's look at the handouts. I think the handouts are okay. Hmm. Let me open the handouts. Yeah, just a moment. Yeah, Python project. Okay, so this is the handouts that will be given to you. Just a moment. Right. So the Titan project is about Titan Industries have just purchased a titanium dioxide plant in mixture. As the management team, which is you, your mission is to recommend a 5-year plan for the site. Okay. Any imminent expenditure plans need to be fully justified. It's about money. So what you need to do is, why there is a titanium oxide plant here, the advantages of disadvantages, and what the various options are for the site, a strategy for the next 5 years. But I think let's look at another one. Working with others, okay, political. What you need to do is consider, okay, the same thing. All right. This is the information on the TiO2 plant. Okay, you can see this is your mission. This reason why the site is good location for TiO2. Propose a strategy and presentation recommendation. There is another one that you need to do. Yeah, Titan Industry have decided to build a new chloride plant, so they require the setting up. Okay, so your task is to recommend a method. Okay, just now is that TiO2 plant. This one is to recommend a method for determination of chloride ions in the effluent. Okay, because there is effluent chloride in the effluent. So survey analytical techniques for chloride, compare the analytical methods, consider the terms accuracy and precision, consider what other factors contribute to the choice of an analytical method, propose and justify to your uh, bosses, okay, to your board of directors probably. Okay, so you have to choose a few methods and define the accuracy, precision, and explain. There are a few suggested methods here, gravimetric methods, titration, and there are some data already given to you. So you can do correlation, you can do regression, you can do statistical study to present your justification to the board. Yeah. Okay. So that will be the second room, second group. Okay, let's look at the third. So it is called Launch a Lab project. So STS contract analysis is tendering for a large contract with Mixture River Authority for the analysis of organic pollutants in groundwater. You are part of the STS management team. Your task is to ensure that the company can deliver a high quality service with suitable profit margin if they win the contract. So these are the scientific skills and soft skills that you should obtain. Okay. Your task, this is the first task, is to recommend one new instrument that could be used for routine analysis for aromatic hydrocarbon. PAH is polyaromatic hydrocarbon at sub ppb level. So make sure that you understand the minimum requirement, okay, how low you can go. So you might consider, this is suggestion, yeah, comparing GC and HPLC, the type of column, the detector as well. Okay. So yes, we have to read about chromatography, choosing an instrument. Okay, since this is a launch of lab, so you have to consider also about cost within an analytical lab. Variable cost, the price for one-off analysis, charging a different price if you're providing a regular analysis of PAH. Produce your recommendation on one overhead transparency. Okay. And be prepared to present this to the managing director. Okay. And then you also need to identify accreditation standards required for the library. Yeah. Library. For the laboratory. Okay. And you also need to think about validation of a method. So how to validate why validation of a method is essential, and to identify the steps required in validation of pre-concentration of PAH using SPE. Okay. All right. So read first. Okay, the last one, Tales of the River, room number 4, Tales of the Riverbank. So Mixture River Authority has received a complaint about perceived reduction in number and size of fish caught along the Kuli River. So as investigating officers, your task is to identify the possible causes and suggest any remedy if required. Okay, so these are your scientific skills, yeah, sampling, analytical techniques, data analysis, these are all you have done. And then the soft skills, whether there is a problem, to confirm it is actually a problem, where and when did it occur, the nature of the pollution, the potential sources, toxicological issues, who could be at fault. Okay, so you have a set of reports. Okay, you have to fill up this survey based on the data. Don't worry, you have all the data. Okay, you have to study the reports and consider whether it is real problem where on the river, the potential cause of the problem. And this is at data that you have obtained on the water itself. Yeah. Okay. So now you can request method sample to be analyzed. What are you looking for? Method of analysis. BOD is biological oxygen demand. Okay. Okay. So it's about sampling. So this data is for water analysis, BOD, COD, ammonia, DO, dissolved oxygen. Okay. You have to fill up the blanks. You have some data from pesticides. Okay, this is some question on suitable analysis for cations. Okay. All right. Okay. 1, 2, 3, 4. So it's okay. Today, because from 8 to 9, you're going to have your presentation. This is your first working together. Okay. So the next one will be this problem-based learning. So give this data to you as soon as possible in Putra Blast as well as in the WhatsApp group. Okay, you can take time to read and we'll give the instruction on what to do next week. Okay, so it's okay. We have enough time to do this. All right, okay. Any question? Okay, no. All right. So see you at 8. Please be on time because you're going to present, yeah? All right. Thank you.
Thank you, Doctor.
Yeah, see you. First, you want to do according to the group number or we can just volunteer basis?
Group number.
Group number. So we have room 1. Can room 1 at least try to prepare?
I will share the screen.
All right. 15 minutes, yeah, maximum. Okay, the presenter, can you at least turn on your camera? Okay, so I can turn off my camera. Have you tried sharing?
Sorry, Doctor.
Who's presenting? The presenter, can you turn on your camera and try to share your slide? Who's presenting for the first group? Okay, Shaira.
Room 1.
Yeah, room 1.
We will
All
be
right.
with you.
So ready when you are. All right. The floor is yours.
So I will
Can you make it slideshow, right?
okay.
Mm.
Is it
Not yet,
allowed to
slideshow.
do not yet?
Mm. Okay.
All right, I will start.
Mm-hmm.
Assalamualaikum and a very good evening. I bid to our respected lecturer, Professor Azhar, and also to all of my friends here. I am Syahira Balkis binti Abdul Jalil. I'm from Group 1, and I will be starting the presentation with introduction parts and also later on the precision part. So for the questions that we got for group 1, so basically this question requires us to do like an evaluation to evaluate which method is the best for the lab to purchase. So we've been given a solution with a null value of 5.5, and also we have 10 replicate measurements of the pH of that known solution using this for pH meter. From this data, we can see that we have brand A, brand B, brand C, and brand D. So the question is, which brand would you suggest for the lab to purchase? So I will pass to Aziza to explain for the first part of the presentation.
Okay, Assalamualaikum and very good evening. Okay, my part is on descriptive statistic of oral analysis. Okay, before that, descriptive statistic or analysis is a summary, provide summary about the sample and also about the observation that have been made. You can see there is a mean, standard deviation, variance, and also confidence level inside the descriptive statistic. It can made using Excel. Just go to the data analysis and select for descriptive statistic. Okay, from the mean here, the brand B has the lowest mean, which is 5.52, indicating that their measurements are more closer to the true pH value. Our true pH value is 5.5. And the standard deviation also, the brand B has a relatively low standard deviation, which is 0.079, suggesting is less variability in their measurement. Okay, next. Okay, next. Okay. This is a manual calculation. If we want to find the mean and also the standard deviation. As we know, mean is the average of all the observation, and the standard deviation is the square is square root of the variance, and this is the formula for the standard deviation. Okay, from here we can get the mean by divide all the sum of this data and divide by the number of sample. And from here we can calculate the difference between individual data minus mean, and we power by 2. And we use this formula, which is square root sum of individual data minus average, the power of 2, divide by number of sample minus 1. And this is example for pH meter brand A. We can get the S is 0.1873. It's the same like my previous slide from descriptive analysis. Next, I will pass to my team.
Thank you, Aziza. Good evening to Prof and everyone. So I'll be sharing on the bias assessment. So what is bias assessment? It's referring to the process of evaluating and identifying the potential biases in a system process, or in this case, it's a set of data. So we know that the true value is pH 5.5. So we are setting this as a benchmark. So we assume the readings for this across these 4 brands were recorded using the same condition as the actual pH testings. So for the equations, bias is equal to average of pH meter readings minus the true value. So brand A, so the pH is having a positive bias of 0.08. So for brand B, a positive bias of positive 0.02, which is also the smallest across these 4 brands, meaning that it is relatively accurate. And also next we go to brand C, pH positive 0.20, and brand D, pH plus 1.41. This positive bias is really significant and also the highest among these 4. So meaning that we are not really choosing brand D for this time. So looking back at brand B, it is consistently higher by 0.02. We can actually easily adjust it back of the pH meter if we're actually not knowing that this bias is there. So next I'll be passing to Shahira.
I'll be continuing on the precision part. So precision, what is precision? Precision is actually refers to how consistent or repeatable the readings are, regardless of how close they are to the true value, which we know is 5.5. So in this case, standard deviation plays a very big role in choosing which pH meter is the best. It's because a lower standard deviation indicates that the values are clustered closely together, thus showing higher precision. So from the table, we can see the mean and also standard deviation for all of the 4 brands. So from this table, we can clearly see that Brandy has the lowest standard deviation of a value of 0.04 and followed by Brandy, which is 0.079. But however, since we also take accuracy in place, which is closeness to 5.5, we can clearly see that Brandy with the mean of 6.91 while B is 5.52. So B is the best pH meter that we can recommend, as it offers a very good balance of both higher precision, which shows low variability, and also a high accuracy relative to the known value of pH. So I will pass the next part to Chen Hao.
Hello. Okay, next page. Hello everyone. Let's talk about which pH matter is more suitable from the suitable confidence interval. At a confidence level of 95% and 9 degrees of freedom, the value of T is 2.262. The confidence interval is equal to the simple mean plus or minus T multiplied by the ratio of the standard deviation to the square root of n. From the table, we can see the brand B. This interval is narrower than the CI of brand A, suggesting higher pressure. The mean of 5.52 is very close to 5.5, and the confidence interval contains the true value of pH 5.5, indicating both accuracy and pressure. Brand A includes the true pH value of 5.5, but its AI is wider. The CI of C is wider, but it doesn't contain the target value of 5.5. Although the CIOD is narrow, but it doesn't contain the target value of 5.5. So at a confidence level of 95%, brand B is the most suitable choice. Okay, next part. Halimit.
Okay, good evening, everyone. I'm Kamarul. So for the last part, where we'll be doing hypothesis testing. On this case, we are trying to compare the data between brand A, B, and C to the true value 5.5 to see whether they have a significant difference between the data set to the true value. So based on the slides, we can see for T value, you can calculate using the formula on the right-hand side of the slide. But for this case, I just use SPSS to calculate everything. You can see from the table for brand A, B, and C, the T value for brand A is 1.35, for brand B is 0.802, for brand C is 2.176, and for brand D is 60.429. By comparing the T value calculated to the T from table, which is 2.262, we can see that brand A, B, and C have the T calculated value less than T table, which indicates that there is no significant difference to the true value of 5.5. Whereas for brand D, the T value 60.429 is obviously more than 2.262, which means that it is significantly different from the true value 5.5. Also, if we look at the p-value from for brand A, B, and C, brand B has the highest p-value, which is 0.443, which indicates stronger evidence to accept the null hypothesis, suggesting that the possible trend towards higher accuracy. So for this case, we are selecting brand B for the purchase. I think that's it. Thank you.
All right, thank you so much. Very comprehensive analysis based on the pH meter. All right. Yeah, very comprehensive, very good. I think we need to move on to second group, room 2. Thank you so much, room 1.
Thank you, Doctor.
Thank you.
All right.
Good evening, Prof. and everyone. So I hope everyone can hear my voice.
Yes, clearly.
I'm Pavitra from Group 2. This is my team, Ayuni, Shafika, Wong Hyang, and Deng Hayu. So I will be presenting for today's presentation. Our topic is for room 2 is about the red candy and green candy of MMM. If we see the question is more like a probability question where they have spilled around 2000 they have spilled around 2000 along with 50 green but they have just managed to collect 1000 of it. So we can use probability to calculate how much have been probably picked up for red So the total will be red candy plus green candy. It's 2,500. So for probability of red candy, 2,000 divided by 2,500, it will be 0.8. So they have managed to collect around 1,000 candy. So the probability for red candy is 0.8. So we just time 1,000 to 0.8. We can get around 800 red being collected for the spill. For second question, it's about absolute standard deviation. If we see normally for standard deviation, we need mean to calculate. But in this scenario, we have they have just mentioned it's just a repeating scenario many times, but we're not sure how much and how many times it's been repeated. So for this type of question, we need to use a binomial distribution standard deviation, where the standard deviation formula will be the number of collected sample times with the probability and 1 minus with the probability. So from here, they wanted to know the standard deviation of the green candy. So by put down the value, so we can get the the standard deviation, absolute standard deviation from the green candy will be 12.65. So the third one is regarding the copper concentration at the 3%, where they asked to analyze on the relative 90% of confidence level, where how many sample we required to reach the 95% of confidence. So they have given a few information in the question. For example, the population standard deviation is 5. Their level of confidence is 95%. Here they are mentioned the sampling precision is 0.5%, as 0.15% is equal to the margin error, which is also is the same, where the margin error is 0.15. So for the formula, we can put the number where Zn is equal to Z power 2 significant level divided by 2 standard deviation times with standard deviation divided by margin error power of 2. Z is the critical value that we can obtain from the Z table using the confidence level given in the questions. So if we see here, the A will be 5%. So for the Z value for 2 tail, we have to divide the 5% and we will have 2.5. So 100 divided by 2.5 is 95.7. So we did change it to the divide by 100, we will get 0.975. So we need to find the 0.9750 from the Z table. And then we need to, from the left side is 1.9. From the 0.950 on upper side is 0.06. So we have to sum up 1.9 plus with 0.06, we will get the Z value of 1.96. So if we know already the Z value is 1.96, we just put in the inside the formula where 1.96 power of 2 times with the standard deviation, which is 5 power of 2, divided by the margin error of 0.15 power of 2. So the total will be 4269 sampling sample should be analyzed to obtain the 95% of confidence level. That's all. Thank you.
Thank you so much, room 2, Pavitra and the team. All right, very good. Yeah, detail on how the sampling and the calculation of samples. All right, thank you. And can we move on to room 3? Room 3. Okay, Tiffany.
Good afternoon, everyone. We are the team 3, and there are 4 team members. The first one is Xiao Yao, the second one is Han Yuqi, the third one is Hao Mei, and the fourth one is Shafiq. And this is the full picture of our question. We will calculate the minimum detectable signal and the calibration curve and the concentration detection limit. And I will introduce the first question. The first question is, what is the minimal detectable signal? To begin, let's look at the data that we have. We have the absorbance of 9 reagent blanks, and there are on the left side of the screen, and at this moment, we only have the data from blank reagents, and the analyte has not yet begun to be measured. So what is required for here is minimal detectable signal of the instrument. And actually, most analytical instruments produce a signal even when the blank is measured. The signal is referred to as the instrument background level. And also the instrument detection limit is the analyte concentration that is required to produce a signal greater than 3 standard deviations of the background level. So next step, we will measure the standard deviation, and we can use the standard deviation equation of the standard deviation, which is at the bottom of the screen, and we can also use Excel to calculate. Just type in equal STDEV, and the result can come out automatically. It's approximately 0.0005634. And finally, the minimal detection signal can be defined as 3 times standard deviation of the blank measurement. Therefore, we can calculate it 3 multiplied by 0.0005634, and the result is approximately 0.00169. That is the minimal detection signal. Next, I will invite the Helmi to present question 2.
Thank you, Tiffany. Assalamualaikum and good evening, Professor Azhar and fellow friends. Question 2 is very simple. It is given a set of data about concentration and absorbance. You just transfer this data into the Excel, which is the column having concentration and absorbance. From that, you select all the data and plot a calibration curve. Then you insert scatter, you click any dot from the calibration curve and you insert trend line. For insert trend line and R square, the regression. From this plotted calibration curve, it is very simple. We know the linear equation is y is equal to mx plus c. So y, from this calibration curve, whatever we pull out the trend line, we got y is equal to 0.7493x plus 0.0476. So the question asks for slope. So the m is equal to slope. So you got the answer is 0.7493. Hand over to you, Han Yu Ching. Thank you.
Okay, thank you, Helmi. Next, I will explain the question 3. Based on the result to the first two questions, the question 3 is relatively simple. To conclude the detection limited, we use this formula triple S divided by M, and the S is standard deviation from the question 1, and the M is slope from the question 2. So the result is 0.00226. And that's all. Thank you. And thanks to the producer of the slide, Shafiq. Thank you.
All right, thank you. Room 3, thank you so much. I think everybody seems to be very well versed and very good. So can we have the last room, which is room 4? All right. Nadia, are you presenting? Yeah.
Yeah, but this moment I'm having like issues to share the screen. Sorry about that. Okay, for group exercise of room 4, so we're given these two questions. From the data given we are to determine the correlation coefficient, which is R, between the amount of toxin produced by a fungus and the percent of yeast extract in the growth medium. So the data of percentage of
Sorry.
So, okay, so the percentage of yeast extract is given. So there are like 5 data here and also toxin. And question number 2, based on question number 51, we are also to determine the R between the dry weight of fungal and also the amount of toxin produced. Fungal or dry weights are given in the question as well. Next, please. Okay, so so for the correlation coefficient, I think this question is pretty direct to find the R. So the correlation coefficient is used as a measure of the correlation between two variables, which are the X and Y. And we'll be using the equation 3.28, which is the Pearson correlation coefficient. This is the simplified version, simplified equation of the Pearson. And also to find the R using this. Next. So we'll Okay, so we'll be solving the question 51 first. So we regard the percent of yeast extract as X and also toxin as Y. And then based from the equation, we calculate X square, Y square, and also XY. Here, just insert, so we'll just insert the value according to the Pearson correlation. And from the calculation, we got R as 0.9142. We also included the calculation using graph in Excel. So from the Excel, linear is plotted. Based on the graph, R squared obtained is 0.8358 and square root of R squared is 0.9142. So this linear plot matches the manual calculation also using Excel. Next. So for question 52, we are to determine the R of the dry weight and also amount of toxin produced, also using the equation of 3.28 used in the previous question of 51. Next. Okay, so from the formula, we regard fungal dry weights as X and toxin as Y. And then we calculated the sum of the fungal dry weights and also toxin. And we also find the sum of X square, Y square, and XY. So based from this, we inserted the values into the Pearson equation, and the R is 0.990. And also, we also calculated using the graph in Excel, and the R square from the equation here is 0.9811, and the square root of this value is 0.990, which also matches the calculation using the equation. Other than that, next. We also included another method of finding the correlation coefficient, which is by add-on toolpad. It is a regression tool in Excel as well. So from the calculation, this is more direct. So from the calculation, the R is 0.992, which is quite similar with only like minor difference rather than using only slight minor difference compared to using the normal function of Excel. So that's all for our presentation.
All right. Thank you so much, everybody. Yeah, this is very direct question, but you have done very well for all the rooms. Very comprehensive, and the explanation is very clear. And I think you are ready to answer my parts in final exam. Shouldn't have any issue if you understand all this well. Yeah, because statistic is more on using the formulas, and I mentioned that you don't have to memorize the formulas as long as you know how to use it, and with softwares, then you can just at least generate the data. But the more important is you understand how to use it. I also have limitations because the one that I have used many years ago, yeah, but minimum, for example, if you're doing analytical chemistry, chemical analysis might be different if you're using, if you're working with biological samples. So that's why after my part, Dr. Helmi will be teaching you ANOVA. So ANOVA will be a lot of variables. And then after Dr. Helmi will be someone, Dr. I forgot his name. Okay, I will introduce you after this. He will be teaching you on software, the usage of software. Okay, so you can use RSM, response surface methodology, RSM, response surface methodology, I think. And there are other softwares when you have a lot of data, a lot of factors in one time. So you need to use software. You can no longer plot Excel, simple Excel. We have to use softwares, yeah, to generate data when you have a lot of data, a lot of factors. Okay, so there are steps of in statistic and chemometric. So I hope that from this practice, you have experience working together with your group members, because you need to do the more complex group assignment. Okay, so I will create a link for you to submit all these slides to me in Putra Blast later. I will update on when you will need. Please keep the slide and then submit to me when the link is ready. And for the first assignment, also very direct questions. I hope everybody can do it. I didn't check. The deadline is 15 November, I think. So
Yes, Dr. On 15.
yes, try your best to submit, okay? Because I believe that you also have other assignments from other subjects. So please keep keep your time. Please make sure that any deadline is fulfilled. Yeah, because you cannot. Yeah, I know that you're busy. You're working, so that's why you have to be more. You have to be alert on the deadline. Yeah. All right. So I think that's all today. What we're gonna do next week, because this is week 5 and week 6. There is one week that I will just give you a free time for you to do the discussion set on the group work, because at least you can save time. You don't have to set another time to discuss. You can use the lecture time to regroup and meet. But next week, I will talk about some of the sample preparation. But I do mention that this sample preparation, you will learn in detail if you are taking separation chemistry. And some of you might be taking elective on chromatography. So you will be using these techniques to do the sample preparation. You will be using you will be studying a more detailed sample preparations. And I think many of you who are working are used to this sample prep. So just bear with us. All right. Any questions before we end?
Doctor, I have a question regarding the assignment. First